Hello everybody, welcome to Bhaskar Reddy Software Labs. Now this is a introductory session for all those people who are looking to make a career on Hadoop. So we will be trying to understand what exactly is Hadoop and who needs Hadoop, what exactly it is and all that. Okay. Now the requirement of Hadoop originated from where we will try to understand. First we will look at a small definition about what exactly is big data. So we know what exactly is data, but we will try to understand what is big data. Big data is a term where we are trying to collect massive amounts of data over a period of time, and that data is getting collected from different sources. It is transactional data coming from a lot of devices that are available online, or it could be business transactions that are generating that data. It could be in the form of emails, photos, or some kind of activity log. Now the data is coming at great speed in different variety and different format, and the data is very, very huge. Now this kind of data, if we want to process, we have problems. What is the problem? Now what do I call as big data? We know what is data and how it is measured. 1 byte equal to 8 bits and 1 kilobyte equal to 1024 bytes and all that. Now if we are crossing something like a capacity of gigabyte, few gigabytes of data, we call that as big data. Now if the data is running into terabytes and petabytes, and if it is too huge, unable to handle, now what kind of scenario you are not able to handle? That's what we need to understand. So what am I going to do right now is I am going to black out the screen. I'll be drawing something. Okay. So just keep an eye here. So this is a small client server architecture diagram what I am trying to draw. Okay. Now in a client server architecture, I am trying to draw a diagram of, say, a database server. Okay, this is my database. So this is my database server. So to this database server, I have multiple application servers connected. Application server 1, application server 2, application server 3, so on, application server n. Alright. So I call this application server 1, application server 2, so on. I have application server n. So like this, I have many servers configured. Now of course, application server is the one which is directly interacting or communicating with my database server. When will it try to interact or communicate with the database server? When a client makes a request. So the clients are connected to application server. So clients will never directly interact with a database server. We know that. Now this is a client server architecture, right? Client server architecture. So I have clients here lined up. Okay. So client makes a request for some data. That data is there on this database. So what needs to happen? The data for that program to be executed need to be loaded where the request came from. So whichever application server made a request, so it has got the program. Now it has to generate a response to the end user. So it will have to load the data or read the data, right? Very good. So we are talking about reading the data. So in order to process the request, we have to read the data. Now request is processed and the client gets a response. Now, if the client is making any changes to that particular data, don't you think the data needs to be updated what is there on the database? Yes, of course. So data must also be written. So read-write operation is very normal or natural or regular process. Right. Now the data is getting increased day by day on the server, right? So I have gigabytes of data today. Tomorrow I'll have terabytes of data. I'll have that is going to petabytes and yottabytes and brontobytes and whatnot. Now, a general scenario where the database server goes down. What is the problem? The entire application is gone for a toss. Nothing is working. Then what needs to be done? You need to have a parallel backup database, right? So you need to maintain another system. That another system must be of equal capacity or caliber of the actual database server. Yes or no? Very good. Which means you and I, if we need to have a backup of this particular kind of database, you need to invest a lot of money. Because you are talking about a database server, it is a very high-end machine. So in order to have a backup of that particular data, you need to have another server, another high-end machine. So you need to have a lot of money there. Correct. So this is all what this works on schema on write model, right? Schema on write. So you need to have a schema, well-defined schema. Only then you can store the data, and only when a client makes a request, you need to load the data, then process it and send the results back to the client. So this is general OLTP kind of scenario what you are looking at. It is good, but to an extent, but not always. Okay. So people realize that data is ever increasing, and that is where we are generating too much amount of data, and processing of that particular data needs to be really addressed to. Then what happened? People wanted to develop something. What is that something? Where did that idea came from? You might have heard about a company called Google. Google. Now what exactly is Google? It's a company. It came into the market with a search engine tool. That's the best search engine tool, right? Somewhere 97, 98, Google was launched, came into the market, became very popular by 2000. So people were very much fascinated, and they wanted to know how Google is doing this, why not we do it? So there were two people called Doug Cutting and Mike Caffarella. These two people started working on a small project in building a tool that was similar to Google. That project was called Nudge. That was actually, they were building a text-based search engine tool. Okay, they were working on this. They started somewhere in 2000, 2001. Then what happened was, Google planned to reveal the secret. Then Google published 2 white paper documents, or you call it as white papers. One white paper was all about how it was storing the data, and the other one was how it was processing the data. Okay, it was all about storage, and the other one about processing. So Google revealed these papers, one in 2003, the other one in 2004. Okay? So they said in these white papers that they are storing the data using Google file system and processing the data that was getting stored on Google file system using MapReduce programs or MapReduce, which is a functional programming methodology or technique to process the data that was getting stored on Google file system. So these two people, Duck Cutting and Mike Caffarella, who were building this particular tool, a text-based search engine tool, they read these two white papers and they really got fascinated. Then what did they do? They started working on this white papers. They tried their best of the efforts to understand that. And what they did is they designed a framework. That is what is called as Hadoop. So Hadoop is a framework. It is open source. And they released the first version of it in the year 2006. And what did they release as part of this particular framework? Is the same two components. What are the two components? What Google did. One was related with storage and the other related with processing. Now they said they released two projects actually. Storage, if you want to store data to work with Hadoop, you have to store the data in HDFS format. Like you are storing the data in Google file system. If you want to work with Hadoop, you have to store the data in Hadoop distributed file systems. And the same data that you are storing, if you want to process it, you have to use a MapReduce programming model. So where did they really actually derive all this from? If you look at, that's what they derived from Google. Of course, Google gave an idea, they implemented it. So HDFS is something similar to, not exactly as GFS, it is similar to. Okay? And MapReduce is something similar to MapReduce of Google. Okay? Fine. So they derived inspiration from Google. Now, forget about Nudge now. Nudge is gone. Why? They had some experience, they gained some experience now from the white papers, the specification document, what Google released. They understood, okay, this is what we need to actually do and this is what we will do, and that's what they have done, and they have released the first paper, first version of Hadoop. Now, the advantage. Hadoop, if you want to install, you cannot install on a client-server architecture. You need to install on a master-slave environment. Okay, that is a master-slave environment. Now, a master-slave environment is nothing but a group of multiple systems that are interconnected. It's a network of systems. At least, if we can understand it that way, that is more than enough. That is, multiple systems interconnected with one another, where one system will act as a master and the other systems will act as slave machines. So we have a master here, and these are all slave machines. Okay, so these are all slaves. Now who is going to govern the slaves? The master. Right. What is the basic storage format that you want to store data if you are using Hadoop? Because Hadoop works on distributed environment. That is a master-slave architecture. If you want to store data, you need to store the data in HDFS format. Now related with HDFS, related with Hadoop distributed file system, there is nothing but, what is that? HDFS. There are two parameters. Let us try to understand this. One is called as block size. The other one is called as replication factor. Right. Now the default block size with which the data is stored on a Hadoop distributed environment or a master-slave environment is a 64 MB, which is very, very big when compared to any other file system. Now replication factor is 3. I will tell about this. Both of them I will discuss. Now let me give you an introduction about the processing that happens on a client server architecture. What happens? What happens is the data is stored on one machine. The entire data should be loaded whenever client makes a request, and the entire data may be processed, or it should be processed, right? Of course, any changes, maybe entire data has to be written back. Correct. Now let us take an example. If it is a 200 MB data or 200 MB file, then what happens? The 200 MB of a file or data must be stored where exactly? In one centralized location. So whenever a request comes to process that data, maybe entire 200 MB has to be loaded. And remember, the database server, where that's a single location, if it goes down, then everything is gone for a toss. But that is not what happens exactly in Hadoop. So depending on the block size, that is one of the very important parameters in HDFS. What happens? This single file is now split into multiple blocks. So this 200 MB file is split into 64 MB, 64 MB, 64 MB and 8 MB. That is what is your total 200 MB of data, right? So that is block 1, block 2, block 3, block 4. So the data is stored in the form of blocks. How the block is decided? How many blocks is the file going to be split? It is again all decided based on the block size value. Of course, that's a customizable value. So there are 4 blocks. So will there be only 4 nodes in a master slave environment or a distributed environment? No. There could be 4, there could be 10, there could be 50 machines, there could be 100 machines. We'll talk about all that. Now what we need to understand is, whenever some data is getting stored on a distributed environment in Hadoop, if it is on HDFS, the data will be split according to Hadoop distributed file system into multiple blocks, depending on what is the block size. Default is 64 MB. So I have taken that 64 MB as the default block size, and I have split that 200 MB of file into 4 blocks. Now what again happens here? Now the replication factor comes into picture. Each block is placed on the cluster as 3 copies. 3 copies. Now why 3 copies? We'll try to understand. That is what is replication factor there. The single file, which is broken down into multiple blocks, is now placed on the cluster multiple times. That is what is the concept of high availability. In a client server architecture, you want high availability, you have to have a backup server, right? Very good. Now here, if you see, high availability is the natural phenomena of Hadoop using HDFS file format. So what do you mean by that? 3 copies of each block is placed in the cluster, not on the master, but on the slave machines. Because the data is saved on the slave machines, I would say data. So where is my data? Data is stored on the slave machines. Correct? So that is my data. As a sample, I am taking 3 slaves. There could be 10 slave nodes or slave machines, or 5 slave nodes or slave machines. Now it all depends on how you are configuring. The database administrator, how he is configuring and installing the Hadoop environment. It all depends how many blocks should be created depending on the block size, and how many times each block must be placed as part of the Hadoop distributed environment or master slave architecture. Is all dependent on the configuration of Hadoop installation. Right. So what is high availability now? A data node or a client system, a slave goes down. Then what happens? Another 2 copies of the same block are available. No problem, right? Clear? So high availability is there. Even one node goes down, you have another 2 copies of the same block available. What if 2 nodes go down? Still you have one more node available where you have one more copy of it. What if 3 nodes go down? Yeah, I know. Rarest phenomena, rare situation. Rare situation. The cluster will be so intelligently designed that it is a self-healing cluster. Whenever a node goes down, the cluster will check for the health. Health is either good or bad. That is the status. When it is good, if it has the required number of replication factor matching blocks placed as part of the cluster. If the number of blocks available do not match with the replication factor, then the health of the cluster is not good. So in that scenario, what will happen? It will run programs internally as per the administrator configuration, whatever the administrator has configured. It will heal the cluster. So it will create another node, or it will copy a block of that particular block which is available on another system. So master will not contain data. So what master will contain? Master will contain metadata. So master will have all the information about which block, which copy, where it is, and whatnot, right? So taking that information, the master will heal the cluster. So it's a self-healing, high availability, and you don't need a very high-end machines. The cost is very, very low, because if you want to work with Hadoop, you have naturally high availability there, right? And it's a self-healing cluster, and it works on commodity hardware. Commodity hardware. Now what do you mean by commodity hardware? Commodity hardware is any system with 4 GB RAM, Core 2 Duo processor or P4, whatever might be the hard disk capacity can be easily added to the cluster. Adding and removing the machines to and from the cluster is very, very easy and manageable. That is not there with client server. I hope you are able to understand. Right? Fine. Now what is the programming model or computation model that we follow in a client server architecture? Whenever a client makes a request, he will make the request to the application server, and the program, whatever is there, it needs to execute and process the request, return the data back, for which we will be loading the data from the database server, we will move the data, we process, and we do all that, right? Now here, Hadoop works on a different principle. It works on data local mode. The computations are in data local mode. That is, whenever the master receives a request, that is a job to process, let us assume it is this 200 MB file, it is this 200 MB file. Now master has entire information about how many blocks of that particular file was created, of course, block size, and how many replicas of that particular file has been made, looking at the replication factor. Now there is a web service which is running behind called as Zookeeper. This Zookeeper will constantly update master with latest information like which node is available, what is the latest information or data available on that, which node is alive, which node is active, what is the process state or process behavior, how much time it is taking. So all that information is what Zookeeper keeps updating the master. Now master, looking at that information and the metadata information what it has about the various blocks and files, how they are scattered and stored, and it has the information about the performance of each node in the cluster, it will decide, okay, this is the job which I need to perform or execute. Which are those nodes which are available in this particular cluster, which are totally burden free and close to one another, where I have these blocks to process. Then the best scenario, what it will do, it will move this job to those slave machines where the data is or the blocks are. So can you imagine 4 blocks needs to be processed, right? 4 blocks needs to be processed. So it will identify those 4 machines and it will send the job. It will submit the program. So the program will execute using what model? MapReduce programming model. And the program will be executed where data is. You don't have to read the data, you don't have to load the data, you don't have to get the data. You simply send the program gets calculated, evaluated where the data is, it will store the results there itself. And of course MapReduce programming, it will consolidate the results and give the results back, which you can send it back to the client. Parallel processing and distributed computing is the biggest advantage. Now say for example, if in a client server architecture you have to process that 20 MB of data, you are taking 20 minutes because there is only one system to process. But if you take, what is this? Hadoop distributed environment, 4 systems will be involved. So that 20 minutes of time is now split into 4 systems, and definitely you will take 5 minutes of time, which is 1/4 of the client server architecture. So you don't have to invest a lot of money. You have a high availability. You have commodity hardware, very, very cheap. It's a self-healing cluster. You have a lot of advantages of using Hadoop. I don't deny, I don't want to tell that client server architecture and OLTP will be outdated. No, OLTP will continue to run, continue to gather information or data, and that data if you want to process, that is you want to meet OLAP services, OLAP, online application processing, then of course you would definitely want to do it very, very quickly and with low cost. And a lot of other benefits are there if you see that. Correct? Fine. So let us go ahead with the presentation. I hope you got it. So who is using Hadoop already? People whom you know like Nokia, Samsung and CS Holding, eBay, American Online, Shopzilla, some of the big companies are already using Hadoop. Okay. So Hadoop big data can be classified into 3 ways. So IBM terms the definition of big data as some data that is generated, any data that is getting generated at great volume, huge capacity, at great speed and different formats. That is what is IBM terms the definition for big data. So velocity is the first time why we are generating data faster than ever before, because we have processes that are getting increasingly automated, right? Yeah, banking process, banking scenario, it's an automated process. Once upon a time you have to go to the bank. Now today systems are getting interconnected. You don't have to go to the bank also, no need to go to an ATM. Today sitting at a desktop or a laptop you can do everything. Payment made easy, payment made online, right? Systems are increasingly getting interconnected, payment gateways are getting interconnected, they are doing a lot of transactions. Now people are also increasingly interacting online. I suppose ours is the best example. We are sharing knowledge and information, trying to connect online, right? Like this many people are doing lots of things. Good. So variety, the types of data that we are producing is in different formats, application logs, text messages, tweets, photos, social network connections. And remember, all of this data is not relational. It is not at all relational, that is, it is not structured. It is either semi-structured or unstructured, right? Very good. Now the volume of data, the result of this is that we are every day generating huge quantity of data. So Twitter is processing close to 340 million messages per day. So Facebook is storing 2.7 billion comments and likes. So Google processes 24 petabytes of data. Can you imagine that? Can you imagine that? It's too much of data, right? And every single minute more than 200 email messages are sent across the globe. Some guy or the other is sending an email to someone else. So there is an application called Foursquare. It is having almost 200 sorry, 2000 chickens, right? So someone is getting connected, coming online and doing lots of things. I hope you are able to understand what we are talking, right? Good. Now what are enterprises expecting? Now we know that big data is something related to volume, velocity, variety. Volume is large amount of data coming at great speed and it needs to be analyzed very, very quickly, and the data is in different formats. So what are the key questions that enterprises are asking or interested about the big data? How do we store and protect this big data? And how do you handle the data coming at that great speed, volume, variety, and how do you store? What is the mechanism? And how do we need to back up and restore that particular big data if just there in case there is any loss of that data? I mean, they are very much concerned about it. Now, how to organize or catalog the data that you have backed up? How do you remember that this is a backup data and this is original data? You see? Now, how to keep the cost low at the same time? How do you ensure that critical data is available whenever you need it? Right? So these are all the questions that enterprises have, and people have come up with a solution, and that is what is Hadoop framework. Now, if you see, more than 90% of the data in world today has been generated in over 2 years span of time. So you never had that much amount of data in 2010. Now 2014 you have tremendous amount of data. So businesses are generating, consumers are generating enormous amount of data. So we are expecting that the entire worldwide IP traffic is going to be quadrupled by 2015, maybe by this year end. And we are expecting 3 billion people will be interacting online and they will be pumping in the data that is approximately 8 zettabytes of data. So there is a big market, there will be enormous amount of data, and we will be asked to work on that particular data. I mean, people want to make analysis and they want to generate some kind of result. I mean, of course, looking at the requirement, we need to really work and get the data. So where did we all start? We started at megabyte, that is what is 10 to the power of 6. But today, we are moving on to exabyte, zettabyte, yottabyte. So the data scientist uses yottabyte to describe how much government data that National Security Agency or FBI, Federal Bureau of Investigation, have on people altogether. So it is in the form of yottabytes. Now we are expecting that we are going to cross even the brontobyte, looking at the amount of sensor data that we are capturing from Internet of Things. Of course, you have RFIDs and different kinds of devices that are generating an enormous amount of data. A flight is expected to generate 10 terabytes of data for 30 minutes interval of time of flight. I mean, that kind of data you are generating. Okay, fine. Now there is data explosion, and are we having an analysis solution for that data explosion or not? That is what is I am trying to show in this chart. Suppose we have a company that was processing say 60 GB of data in 2002. The same company is forced to process 60 terabytes of the data. I mean, it's almost 1,000 times more data than what it was processing 10 years ago. Yeah, that is the requirement. So most of the companies are looking at that they are generating 35 to 50% of data every year. The data size, volume is increasing. Now why is this increasing? You cannot stop it, right? You cannot stop it. I mean, you have an application, you have support, you are doing something, and people are exchanging data and information. So you cannot stop it. So those companies, they have, I mean, those who have implemented some kind of tool or the other in order to manage this data, in order to do some predictive analytics, they are able to retain more than 6% of their customers. And those companies who are not able to handle the data explosion scenario, they are losing more than 1% of the customers. Okay? So people are moving on. So top performing companies or organizations are using 5 times more than the lower performers. There is an enormous amount of data. Now what are the most important factors driving for the growth of data globally is because now you see everyone is using mobile and they are using internet and mobile. You already have a lot of applications on cloud and they are using those applications. People are interacting with applications directly. That is what is you are trying to work with collaboration. Or not only collaboration, you directly try to communicate with a payment gateway and you do lots of things. And you have IP based message communication, maybe an online class, or VoIP, you make a call to 200 countries, more than 200 countries, right? You don't need a telephone line today. So social media, of course, it's there, Facebook or Twitter or anything. Now you have video and audio on demand, not like once upon a time where you used to have TV on one channel. Maybe on weekend you watch a TV, you have it, you don't have it, maybe you go to neighbor's home. Now today, no neighbor's home, no TV, no problem. You have internet, you have your laptop, you like something to watch, whichever movie you pay and watch, right? Good. Things are changing. So where is this all big data coming from? Do we need to get it from somewhere else? No. Internal to the organization, there is a lot of data in the form of transactions. So you have 88% of the data in the form of transactions, 73% of the log data, and you have data 57% of it is already there in the form of emails. So a little bit of data is also there available external to the organizations in the form of social media, audio and photos and video. So 43% of social media, so 38% in the form of audio and 34% in the form of photos and video. So this is what is a survey that I have conducted. I have collected the data from IBM, what it has conducted. So this is a bubble chart showing the GDP contribution of different industries. You have manufacture, you have professional services, accommodation, food, construction, administrative services, other services, government, finance and insurance, transportation, warehousing. A lot of companies are there. So how much they are contributing to the growth of a country. So that is what is a GDP metrics. So this is taken from the US economy, any other country the same. So this is a study conducted by McKinsey Global Institute. So that's the full report. So which application scenarios big data solutions will be used? Of course, someone who wants to increase their sales figure, 32% of applications in that. So improved risk management, someone wants to do new business, or maybe they want to invest somewhere, making their finances better. Improved management control, when to hire whom, when to fire whom, so that kind of things. IT analysis, of course, which kind of projects if you can do, say Ambani or Birla or maybe someone else is sitting there, they want to make a decision, which project to bid right now, what is the best season, when to hire. So you have a lot of freshers coming in, so you get a good pool of freshers coming in, so you can bid what kind of projects, what level, which is the technology which is very easy to learn. So that kind of decisions you want to make, that's what is IT analysis, right? So better customer service, you are selling some products, you want to provide best customer service. What is that? How do you do? Which country do you go? Where do you set up a BPO? Where do you set up what, right? How you can make that possible? Of course, order to manufacture, that is what is the industry or the world is revolving. More market-oriented product development. Now, you make a lot of research and you decide which country, which kind of quality product goes in. So you try to manufacture that there, or you try to export it there, or try to import it there and try to sell it, right? Maybe. Otherwise, if it is very huge, it involves a lot of investment. Then you say, please place an order, pay this much. Then I will try to manufacture and deliver. Please wait for this time, this much amount of time, then I will, yeah. Of course, coming to optimize logistics, shipment of goods from one place to another, how do you optimize it? Of course, I'm working with a group of people who are with a company which is involved with logistics. So we are onto that as well. So these are the two pie charts which are showing a scenario where someone who believes that Hadoop, what exactly, this is just a marketing hype, come on, it's not going to work. Someone says like that. Someone else is telling that no, this is a new generation database and very good analytics technology, no, we need to learn this. So we have three categories of inferences made here, people who strongly agree, people who agree, and people who partially agree. If you look at a new generation of database, if you club, to be very honest, if you club these two, people who strongly agree and agree, this is almost 79% of it, right? Imagine, that is very big, huge when compared to this 67%. You are almost 12% more on the better side, right? Of course, 21%, 31% partially agree. Means, don't you see that 11% are also on this side? Correct? That's what it is, right? So that's what how you need to analyze things. So It is for future generation. Of course, any technology that comes into market in IT industry, it will definitely stay for a period or span of 10 to 15 years. So there are a lot of implementations going on, a lot of distributions getting created. I don't say Hadoop is only for 5, 10, 15 years, maybe beyond that. I don't know. Right. Now that's a 20 billion euros market by 2016. That is what is the projection. Now who wants to make how much money they can make? So there are 3 different industries which can really make big out of it. Big data services. What kind of service you want to provide? That industry is going to make a lot of money. The least is going to be new big data applications and analytics. Very few. Of course, big data infrastructure. You already have data banks. You want to provide a cluster. You want to design. Of course, you will be making good money. Good money. So you want to get into big data services, maybe using Hadoop framework. That's what many companies are doing. They are trying to design distributions and sell across the market. Okay. So people are investing hell a lot of money, so you can find place. Now this is what is information explosion and the analysis gap. That is, right now, today in the industry, we have what applications which can process data coming at this volume, variety and velocity. As of now, that is what is the capability of application which is already developed. But we are generating this much amount of volume of data, variety of data and this speed. Now imagine an application which is having no scope to process data at that speed and that volume and velocity or variety will definitely not give correct results, right? So when the result is not correct and you try to converge and make a decision on that particular result, definitely that result and the decision both are wrong. So that is what is the analysis gap. Okay, fine. So that is what is Hadoop creation history. I was telling about Nudge project, Duck Cutting and Mike Cafarella. They started somewhere in 2001, 2000 and they were working on it. In the middle, Google published 2 white papers, 2003, 2004. One was Google file system about storage. Other one is MapReduce in 2004. So these 2 people studied or experimented a lot on or researched on that white papers. Then they said, well, maybe, so why not we do it for Nudge. Then they did it. Then they moved ahead, and the first version of Hadoop they released in 2006. Okay. Then after that, the first implementation converting New York Times data of 4 terabyte on 100 systems, few $100 and a week's time, a week to 10 days time. The project which would have costed few thousands of dollars and few months of time was possible only because of Hadoop. Now in 2008, Facebook launched a tool called Hive. Those who know SQL, they can work with Hadoop by using this simple tool. Of course, we will be learning that tool. Okay. Now in the same year, a company called Cloudera was founded that has a distribution of Hadoop framework. So they have a lot of tools, products there. We'll be learning that. Now in 2008, the same year, the fastest sort of a terabyte was performed in 3.5 minutes. The same record was broken again. The fastest sort of 1 terabyte was done in 62 seconds as compared to 3.5 minutes earlier. Of course, the number of nodes that were involved and all that, it's all does matter. So there was a summit in 2009 conducted where 750 attendees or companies attended. Now recently, last year, 4,500 attendees, 4,500 companies, they have shown interest and they have teamed up, and the Duck Cutting and the team have joined Cloudera. Okay, so Cloudera and Capgemini are now teaming up and doing a lot of work in India, and of course, so there's a lot of hiring going on. Okay, so I assume that you have understood what exactly is Hadoop, why do we use Hadoop, and what is it meant for, and I hope you know the exact difference of where people are going to use Hadoop. Of course, to be very precise, there are a lot of distributions available in Hadoop. Let me clear the screen. I'll be writing something again. So this time I'm going to clear the screen and I'll type here. So there are, see, Hadoop is a framework. Okay, that's a framework. Now this is of course, okay, this is open source. Now there are a lot of companies implementing this framework, and they are developing tools. There are lots of companies. There are too many. I cannot name. I can name only a few. Say IBM is one. Okay. You have MapR Technologies. You have Cloudera, one company. Okay. Cloudera is one company. Now, you want to work with Hadoop, you have to take any of these distributions. Cloudera is free, basic version of it. It can be installed in three modes. What are the three modes? It's on one machine, one system, also called as standalone mode. Okay? Generally you do it when you are developing something or you are learning it. Okay? On two machines, the second mode of distribution, what you do? That is what is pseudo distribution mode. That's a pseudo distribution mode. Generally not in production but in test environment. Okay? Now on infinite number of machines, that is what is exactly a fully distributed mode. That's a fully distributed environment. That is what is production. Now we will talk about all these three. We'll be talking about the configuration files required. We'll be sharing with all the documents. Now, the prerequisites to do this course, anyone should have core Java knowledge, basic Unix commands. Now, why is core Java knowledge required? One reason, because we will be learning MapReduce programming. For that you need basic Unix commands, idea at least. Something like how do you create a file, how do you create a folder, how do you place a file inside a folder, how do you move a file from one folder to another, how do you move a folder from one location to another. That's it. If you can know that, then you should or you will be very comfortable with HDFS shell commands. Just in case if you don't know core Java, we'll give you a 10-day orientation program on core Java, maybe a day or two on basic Unix and HDFS commands. Okay. Now apart from this, say someone is not interested in MapReduce programming and core Java and things, then you have tools like PIG. It's a tool from Yahoo. They have developed it for themselves. Later on they have contributed to the community. Okay. Then you have a tool, Hive, from Facebook. They also have developed it for their own purpose of big data processing. Then later on they have contributed to the community. We will learn about Hive as well. Then you have HBase. This is a column store database, something similar to Google's Big Table. Okay. The database that Google uses in order to process or for it to process the data, it is Big Table. So HBase also we will be looking at. Now apart from this, we will be looking at data migration tools. Data migration tools like we want to move the data from RDBMS environment into Hadoop or HDFS. Then you have Scoop. So that is for structured data. You have some log data or you have unstructured data. Then you want to move that. Then you have Flow. Okay. So these are the two tools we will be looking at. So simple CLI commands. How do you move the data from RDBMS to HDFS, process it, put the data back from HDFS to RDBMS. Okay. Then we will be looking at the theoretical concept of Zookeeper and Yarn. Now this is Yarn stands for yet another resource negotiator. This is MapReduce version 2. Okay, that is MapReduce version 2. So Hadoop version 1, 1.2, you have Hadoop version 2, 2.0, 2.6. So we'll be looking at Hadoop second generation as well. Okay, now you'll be learning these many things. How do I go about, where do I start, what do I get? Now whatever videos you are watching, if it is online you are attending, you will get your video as a link you can watch later. If it is in classroom, you will get a video link of some other class. Okay, the advantage, you can rewatch the video and maybe you can try to interpret the concept just in case you could not get it in the class or for the first time. And of course there are too many contents, then how do you manage? That is the reason why we will be giving you step-by-step documents. We will be giving you all step-by-step documents for all the topics that we cover. Now it will be so interactive, or in fact so helpful, that even after you do the course or complete the course, keeping the video and keeping the document, you should be quite comfortable to do any exercise or whenever you want to start something from zero or scratch or basic level. Okay. Now why we are covering cloud era is one question anyone would ask, because cloud era is proven, tested and quite successful implementation on Hadoop. It has more than 50% of implementation on Hadoop are on cloud era, which all other distributions put together are also not equal to cloud era. So for that reason we are picking up cloud era, otherwise no. Yes, we do teach you installation. Now Hadoop can be learned in the following areas. First one is admin, second one is development, third one is testing, fourth one is maybe performing ETL operations. Now we are only focusing or concentrating on development for one reason: the number of jobs or openings that you have, or the scope and life of a developer is more in any area, and that is true even with respect to Hadoop. Of course, the number of developers in a company will be more when compared to admins. Of course, testers, we are not really interested because you need to be a developer in order to be a tester in Hadoop. So you learn development anyhow, you will learn automatically testing in future. Now ETL, most of the situations data is already cleansed, or maybe a little bit of effort if you can put in there later on, depending on the requirement, you can do the cleansing of the data and you can do. So the most sought after area where you can find more number of jobs will be on development. Maybe right now these many tools, if you can have an overview, it's okay. Any one tool, either from programmatic part MapReduce or non-programmatic Big Hive or HBase or all together, that is what is the demand of the market. Maybe going down the line 6 months or 1 year, maybe if any one tool, if you know, maybe you should be able to fit in a job, or if there is a requirement you can squeeze in. So that's what is all our intention to tell you. So if you can start quickly, it's good, better. You can be in the bus already and you have some breathing time. Maybe you lose the time, maybe you have to spend little time to catch the bus. So maybe you have to exert a lot, then pressure would be too much. So if you can start early, that is what is good. That's what we suggest or recommend. Of course, it's all up to you. So that's it for the introductory session from Bhaskar Reddy Software Labs. So brief overview before we sign off. I am a trainer here. I worked as a project manager, technical architect. I started my career. Of course, let me introduce myself. This is Govardhan here. A postgraduate from Usman University, MCA in 2002. 12 years of experience, wide variety. Started somewhere with CUI, Black Window applications, DBase 3+, Fortran, Pascal, COBOL. Later on migrated to .NET. Yeah, experience with Windows application. Moved on to web on .NET. Later on got fascinated with Java, then moved on to Java, then worked currently managing projects both on Java as well as on .NET. Of course, good with the databases like SQL, SQL Server, MySQL. Good with databases, so intention is to learn new technologies and train people, as well as manage my team and projects and clients. That is what is the motive of handling multiple things. So this is a company which is 10 years old today, and you can believe and rely on this. It's all what it needs. Anyone is to put real conscious effort to master. So it's going to take not real short span of time to get Hadoop and hands-on and good with it. It will take definitely 3 to 6 months of time, maybe 45 days. We will finish the basic course, maybe another 1 month or 2 where you need to slug it out. Then you should be good to go and handle. So it's very simple, provided you practice and get good hands-on, not a big deal. So hope to see you in some other session. So thank you very much once again on behalf of Bhaskar Reddy Software Labs. Thank you.